Uber burned through its AI budget faster than anyone expected. Microsoft started cutting internal AI tools licenses because cost kept climbing. Everyone is talking about it, but here is the thing. This is not just a big company problem. So this is my solution to solve it. I used Coral, open source tool that turns any API into SQL tables, GitHub, Sentry, Datadog, Slack, all queryable with standard SQL and cross sources joins. I built Sentinel on top of it, and this is what it does. These are the 5 ways AI agents silently failed in production. Nobody built a single tool that catches all 5 until now. Problem 1, agent loops. And here is what makes them dangerous. They don't look like errors, they trace complete successfully. The agent just called the same tool 47 times, convinced it making a progress, but it is not. Sentinel groups Langfuse generation by trace IDs, counts, repetitions, fingerprints, argument patterns. When a loop fires, I know the trace ID, the cost velocity, and the exact tool that's spinning in real time. Problem 2, prompt drift. Someone edits the system prompt, one line changes, the output structure shifts. Whenever parsing the JSON downstreams, start silently misreading it. No error thrown, no alerts fired. User just starting getting worse answers. Sentinel maintains schema snapshot per feature. When the validation fail rate crosses 15%, it joins with commits and find the exact commit that caused it. Basically, it just blames the grid for prompt regression. Problem 4, autonomous agents executing high risk action with zero checkpoints, no approval trial, no record of who knew what and when. Sentinel acts automatically, low confidence, with quiz for human reviews. The web UI is the audit trail, every decision made, who made it, and when they made it, and what happened after. Problem 5, telemetry saturation. AI system logs everything, most of it is a noise, and the team paying attention to all of it are just the ones breaking their observability budgets. Sentinel scores every trace, errors, cost spikes, novel pattern get kept, routes successfully, calls get dropped. In the demo here, and before any of this ships, Sentinel scores every PR. It looks up to the historical record of every file being changed. These two files have cost spikes and loops events before. The scores reflect that. The reviewer sees it before they merge. This is what I am most proud of. Click any incident, Sentinel builds your full causal chain. Commit node on the left, sanitary errors nodes, Langfuse cost spike nodes, Slack threads, nodes on the right. Every node shows the time delta and cost impact. But here is what makes this different from any other observability dashboard you have seen. This entire graph is assembled from single cross-join Coral SQL join across 4 different APIs in real time. This is the query binding it. One SQL statement, GitHub, Sentinel, Langfuse, Slack, all in one shot. When you have spent 3 hours doing this manually with 4 browsers tab open, seeing this feels like something shifted. This is the second moment when Sentinel detects a loop. It does not just alert, post an interactive Slack message. The agent is sitting here waiting for your decision. The message updates to show the action taken. A GitHub issue gets created automatically with the full root cause analysis attached. An audit record is written. The original message now shows who approved it and exactly when. The whole writeback flows runs through a custom fast API webhook with HMAC signature verification because Slack ends the button callback to an endpoint and the endpoint has publicly reachable and authenticated. Under the hood, every piece of data Sentinel uses comes through a Coral SQL called via subprocesses. The Python run agents, the CLI gets back JSON rows, run detection logic on the top. 7 sources, Langfuse, Sentinel, GitHub, Slack, Datadog, PagerDuty, Linear. Cross source joins work exactly like SQL because they are SQL. That's all. Thank you.